Okay, hello everyone. My name is David, and today I'm here to chat with you guys a little bit about AWS Cognito and exploiting some misconfigurations. Let's get going. So today we'll talk a little bit about who I am. I'll share with you guys about what AWS Cognito is, sort of what are the key features and functionality, what problems it tries to solve. And then we'll go into some of the ways that AWS Cognito could be configured, and in some cases, maybe misconfigured. And then I'll explain some of the specific techniques you can use to actually exploit those configurations to make the application that's using AWS Cognito do unintended functionality. And in the end, the idea is to, hack the app or break the app using AWS Cognito. Lastly, I'll discuss some prevention measures as well, so that the security engineers out there and software engineers can hopefully use some of this information to prevent some of these issues in their software products. So let's get started. So who am I? My name is David. I am a security consultant at Bishop Fox. I predominantly focus on web applications and cloud environments. I generally work with large software companies, also play a role in sort of leading pen testing activities at large software companies, but generally do a lot of web applications and cloud environments in that realm. I also went to NYU, so I went to the engineering school there. I still live in New York, and yeah, very proud of being a New Yorker. I'm also an Arsenal fan, so if anyone likes the watching the Premier League, I I really enjoy it. Arsenal is finally good after the last, 7 or 8 years, or rather, very good after the last 7 or 8 years. So it's been pretty exciting the past few years to be an Arsenal fan, and not as embarrassing as it was in the past. So yeah, a bit about me. So let's talk about AWS Cognito. AWS Cognito is a service that AWS offers, and it's predominantly leveraged for software engineering teams to abstract or basically have like a pre-made component that does authentication, authorization, and user management, predominantly for web and mobile applications. There are two key concepts in AWS Cognito, and the first one is the user pool. And the user pool manages the user profiles, or the users in your application, and then it also handles some of the authentication that would go into logging into a website or logging into a web app. Then there are identity pools, and identity pools will basically be in charge of mapping permissions uh, of the users in the user pool to AWS resources in the AWS environment. So identity pool is sort of like the thing that grants permissions to users to access AWS resources. And together, these two components, the user pools and the identity pools within AWS Cognito, sort of build this product that simplifies the sign up, sign in, and access to AWS resources that would be leveraged within your web application. Here on the right, we see a graphic that sort of goes through one of the more common use case scenarios. So you'll see an app connecting to a user pool to authenticate. And then in that authentication process, you can also federate authentication. So you can leverage single sign-in, OIDC, or other sort of authentication frameworks. Then once a user is authenticated via that user pool, then you can actually build functionality with Cognito to retrieve sets of tokens or credentials to access AWS services themselves. Um, and yeah, so maybe like an S3 bucket or an RDS instance. Um, yeah, if those services are in your application, this is a good way to grant users permissions to use them. All right, so that's AWS Cognito. Now that you guys are experts at AWS Cognito, let's chat a little bit about some potential misconfigurations. And so I think a keyword here in potential is because these configurations in AWS Cognito don't necessarily mean that they are a misconfiguration or introduce a vulnerability. For example, this first one we see on the left is self-registration. That you can kind of think of that almost like as a self sign up or a sign up of on a web application. And if you enable signing up on a web application, that's not necessarily a vulnerability. All these configurations could be vulnerabilities in the context of the application, in the context of the design of the application. So, how can self-registration introduce a vulnerability? Well, let's say there is no such thing as signing up for this web app. Let's say you're using AWS Cognito to authenticate admin users to an internal admin panel. In that scenario, you probably don't want any user that visits this admin panel to be able to sign up and then just become an admin. So in that case, it could be a vulnerability. But let's say it's just in charge of doing the sign up of a public facing web application, it's probably not a big deal. It's honestly probably intended. Next is the modifiable user attributes. So user attributes is a functionality that in AWS Cognito for user pools. And so those are a user pool is sort of, you can think of like the sets of users in your application, kind of like what you might have in the user table in your database, in your Postgres database. So you'll see these attributes, and they can actually be key value pairs that the application itself can use to, let's say, identify a particular role. So kind of like in JSON Web Token, where you might have a key of like role and then a value of admin or value of user, and then your application would authorize certain actions based on that role in the JSON Web Token. And so this is very similar. This is basically the same functionality where you're creating these custom attributes and assigning custom values. And then down the line, through your authorization flow, your application may take a look at those values and use them to serve up some information. And lastly is the exposure of a client secret. So I won't go into the specifics of how AWS Cognito can integrate into um, other applications or other services, but know that there are many ways of configuring AWS Cognito. And one of those ways is to integrate it into external applications, either within the AWS realm. So, for example, AWS has um, a service called, I believe it's called OpenSearch. It's kind of like an elk stack. So you have like a Kibana dashboard. And so you can actually integrate AWS Cognito pretty smoothly into that service to authenticate users and give them access to the Kibana dashboard. Um, in those instances, or in many instances where you're integrating with something with another service, you'll have something called a client secret. And a client secret, it will always be super secret sauce, as you see the value there. Um, the client secret is basically just almost like a password. It's definitely a credential, it's a sensitive value, and it is used to actually authenticate and sort of like enable some of the really common workflows, such as like signing up. So if you sign up a new user, you might need the client secret. And that client secret would be abstracted in the back end or on the server side and hopefully not exposed to the front end application where end users would see it. Cool. Let's continue. So let's chat a little bit about exploiting self-registration. So as a reminder, self-registration is a feature in AWS Cognito where you can allow other users to sign up for your application or your user pool and basically create a new user and be that user in your user pool. And so, generally speaking, let's say you're assessing a web application and you're in Burp and you're seeing some traffic during the sign up phase or during other functionality where traffic is going to a particular domain that kind of looks like this. You'll have usually sometimes a custom domain, sometimes a default domain, .auth.region, and then amazoncognito.com. In traffic to and from there, you will basically see in the HTTP sort of the URL parameters, you'll see values labeled client ID. And so this client ID is the user pool client ID. And this value is basically a unique identifier for the user pool that you can actually interact with unauthenticated with the AWS CLI. So here in step 2, where you sign up the user, and to remind you, what we're doing here is signing up a user to a user pool to gain access to whatever users on this user pool have access to. So here's the literal command. This is generally pseudocode, so you might have to, and also the AWS CLI changes every so often, so please just reference the latest docs. But the theory is this, that you first sign up a user, and then you'll likely have to pass it, the username may be an email, or you might have to pass it additional parameters in this request to give it an email so that it'll send a confirmation code, and then you'll confirm the user or confirm the user account, and then you log in. And then after you've logged in, you can actually request a right after you found an identity ID, you can actually move on to requesting AWS credentials that are mapped to a role, and that role has permissions that have been created that are mapped to authenticated users of the user pool. Now, it's not necessarily true that anytime you can register a user in AWS Cognito for a user pool, that there will be permissions associated with it. When you're creating or implementing AWS Cognito, you create the user pool and then you create the identity pool. And the identity pool is sort of that key factor that will assign permissions and assign roles to users in the user pool. So if that sort of configuration is incomplete, you may be able to sign up and create a user, but you won't have any permissions to do in the AWS account. So a key portion here is that there needs to be an identity pool associated with the user pool. Now, the identity ID or identity pool ID, these are different, but you could think of it just as like two unique identifiers for components of the identity pool, are probably going to appear in subsequent traffic, especially if you're signing in or signing up a user through AWS Cognito. And if you're looking at the traffic in Burp, you'll probably see some value that's sort of similar to identity ID or identity pool ID. So what you're looking for is the identity ID. And so again, the last step of this is to retrieve credentials for an identity ID, an identity pool ID, and then you need to pass it a token. And that authorization token is retrieved when you log in step 4. So to sum everything up, when you're exploiting self-registration in an AWS Cognito implementation, you first understand or look at the traffic to see and look for the client ID. You then sign up a new user. You might get an error, and because the AWS Cognito user pool is saying no, you're not allowed to sign up a user, and so then kind of sad. But let's say you can, right? You sign it up, then you confirm the user, and then you log in and retrieve a token. And then you use that token and an identity ID value that you should see in subsequent traffic when successfully logging in or signing up a new user for the user pool. And you use the token and the identity ID to then retrieve AWS credentials. And then you have programmatic access to an AWS account through this self-registration configuration in AWS Cognito. All right. Modifiable user attributes. So if you recall, these modifiable user attributes, this is a custom setting, I believe, when you're implementing AWS Cognito in your environment. Um, and what this allows you to do is to create custom key value pairs into the token itself, actually, that Cognito will provide you the JSON Web Token when you're logging in a user. And so there is functionality to actually let users modify the user attributes. And so the scenario here that we would be exploiting is I create a new user and my user gets the role custom attribute of value user. Then the AWS Cognito implementation, for whatever reason, has decided to let me modify my user attributes. Then I modify my user attribute to role equals admin. And then I authenticate again, I log in, and now if the application is viewing these user attributes and assigning a particular, sets of permissions, or maybe using that role to grant authorization to access to other information, I may be able to perform something like a privilege escalation due to this configuration. Yes. So again, all in the context of the application. But yeah, that would be exploiting one instance or one sort of scenario with this modifiable user attributes. The exposure of the client secret. So this client secret is created or generated when AWS Cognito integrates with other applications or other AWS services, and it usually when it's created, it usually becomes necessary to perform all of the common functionalities such as sign in and sign up. And so sometimes you may, query get to the front page of a web application, and if the web application is using AWS Cognito to authenticate an authorization resource and authorize users, then you might see this client secret hard coded into the front end assets to basically authenticate and authorize users to the AWS Cognito instance. So when you see it, this can allow you to exploit some of the two scenarios that we just walked through, because they might this client secret might be required in those workflows. Okay, identity pools. So remember, that was the component of the user pools that handle the authentication and some of the authorization and sort of that use the sets of users in AWS Cognito. And the identity pools are in charge of assigning permissions in the AWS environment to particular sets of users in the user pool. And so this is sort of the last line of defense of, okay, you have a user that you've created, or you have access to a user via Cognito. Now, what can this user do? What is the sort of impact or maybe blast radius of a compromised user? And as with most AWS services, IAM permissions plays a key part here. So this first misconfiguration, again, also depending on the context, these configurations um, may be on purpose, maybe you have a good business use case, or they may not. So it really depends on the context. For this first scenario here in the unauthenticated access, identity pools have features or functionality that will basically allow unauthenticated access to the identity pool, which means that if I or an attacker or a user or an application just knows the identity pool ID, it can actually retrieve AWS credentials for the unauthenticated for an unauthenticated role in the identity pool. Depending on the permissions assigned to that role, it could have an extremely limited effect, or it could be pretty intense or pretty severe. So yeah, that's they call it guest access. Yeah. So overly permissive IAM rules. This is critical in all of AWS whenever you're engineering a solution in AWS, but it's very likely, or rather common, that IAM roles and the permissions that are defined and attached to those roles may be overly permissive. And so you see here the design is just some of the more permissive roles that I've seen attached to some principles. Then the exposure of identity pool ID. So this identity pool ID, I wouldn't say it's a big deal. It might have many use cases where it's not an issue, but if possible, ideally, your application is probably better off in the worst case scenarios to keep this value in the back end or in the server side and not necessarily shown to the front end assets. And that's because it's kind of like a unique identifier that natively in AWS users, attackers, anyone else can leverage to try to start to poke holes against the configurations of the identity pools. All right. Exploiting unauthenticated access. So yeah, the prerequisite for this one is just finding the identity pool ID or the identity ID. These values are likely to be somewhere in the front end assets or somewhere in traffic, in HTTP traffic that you'd be proxying with something like burp. Looking at when interacting with the web application, especially when you're doing the sign in and sign up functionality there. So the theory here is all you do is, let's say you have the identity pool ID, you can retrieve the identity ID from the identity pool ID, and then use the identity ID to just get credentials. And this will get credentials for the guest user or the unauthenticated user. Overly permissive roles. So this is not only applicable for AWS, but also very applicable, Cognito, but also applicable across any security assessment, pen test, or red team you're doing in the AWS environment. So here we have two roles that I've seen attached to an authenticated identity pool, um, the authenticated users in an identity pool. And so, as you can see, these are relatively permissive. You'll have in an IAM policy, you have the concepts of an action, which is usually some sort of permission based on the resource type, and the effect is usually allow or deny, and then the resource, which defines what resources. So, you know, software products in the AWS environment, what actions you can take against what list of resources. So rather, what list of resources can you take these actions that are defined here? That's a better way of putting it. So here we see resource star. That's probably not great because you can, and then an action under action S3, we have so you can perform any action or any action for S3 on any resource in the AWS environment. Of course, the S3 resources can have some access policies associated with them, so you sort of need those two to kiss, those two to understand each other for you to actually perform the action. But in the scenario where there wouldn't be access policies attached to the S3 buckets themselves, then you might run into trouble if a role with this permission or this role, a role with this permission gets compromised. On the right, we see secrets manager read write. Yeah, read all secrets in secrets manager, and that's where you might find, or you should probably find some sensitive information. So yeah, exploiting these is basically understanding what permissions there are associated with that unauthenticated or authenticated role incognito, and then figuring out what the paths are to sensitive information. Usually that is maybe a conversation with the client or just looking at some of these resources that would be affected like secrets or S3 buckets and understanding where sensitive information is and then mapping it back to the Cognito users that you would have access to. All right, exposure of identity ID. So again, this identity ID value or identity pool ID value is not necessarily very critical that it is hidden from external users. However, if possible, it'd be kind of nice to put it in the server side and not necessarily reveal it to the in the front end assets or to or maybe in traffic. Maybe you kind of be forced to in some cases, but yeah, to try to protect it a little bit more if possible. Here, this code also, so this pseudocode, I don't know if this code works, but back a year ago or 2 years ago now, when ChatGPT was a big thing, I think this was one of the first times I was using it to help me generate pseudocode to explain concepts. I think it's been edited since then. I hope it's been edited since then. But yeah, now that I'm looking at it now. Okay, so, before we go into preventing some issues, I'm going to show a quick demo on how we can exploit some of these configurations and an attack path to a privileged user. All right, we've deployed AWS Cognito Lab to show you what it would look like when user attributes are mutable and the application relies on that mutable attribute to identify a user's role. So in this case, we're going to exploit that configuration by creating a new user with a regular role and then escalating privileges to an admin user by changing that role attribute in AWS Cognito to admin, and then in the application, we'll see the impact. So first things first, let's register a user and wait for the confirmation code. We'll use the collaborator server to facilitate this. Okay. Use the second one. And we will wait for the email to arrive. Here it comes. Okay, let's look for our confirmation code, which is right here. And this confirmation code is probably being used in the backend to confirm that user when we register it in the AWS Cognito user pool. I'm not sure, but it's likely. All right. Do I remember the password? Let's see. I do. All right. So let's take a look at this traffic here. We confirmed it. All right. Here we have a session token. I believe this is the login. Yep. I have my super secure password there. And so here is the JSON web token that we're going to actually use to communicate with the AWS Cognito API. So we'll leverage the CLI here. Let's set this token value. Fantastic. Let's set this token value as an environment variable here so that we can easily reference it and we don't need to be copying it and pasting it. Okay, let's test this out. All right, fantastic. So now let's use this token for the new user that we just registered to get the user attributes. And so we can actually do this without authenticating through the AWS CLI. So I believe it's something like this. US East 1. And here we'll pass our access token. And we'll use JQ here to just pretty print this. All right, let's see what happens. Okay, so here we have our username, XYZ1. We have our custom role, which is role user. Now, what we're trying to do is escalate this user to an admin role. So let's modify this custom attribute in AWS Cognito that the application is using to reference and actually use that custom role value to define value and perhaps access to sensitive information or some sort of administrative functionality in the application. So instead of get user, we will update user attributes. And we will pass in something like this. Custom role, the same thing that you see here. The name, this is the name of the user attribute. And then value equals admin. The region, access token, blah, blah, blah. All right. Hopefully I didn't put any errors here. Let's take a look. All right, no errors returned from the AWS API. So let's take a look at my user, my AWS Cognito user, and we're authenticating to the AWS Cognito API using the access token that we got from the traffic. And hopefully our role has been modified. All right, great. So take a look. Our role has been modified to admin. Now on the left-hand side, you see in this application, here it's, as a lab, we're trying to make it easy and obvious for us. So we're just a normal user. We can't see other user lists. So now that we've updated our role to admin, let's reload the page and we should see something different. Oh, there you go. And this is when I was practicing for this, or rather this is the live one and this is just the previous practice one. So all right, here we have officially exploited the situation where user attributes in AWS Cognito were modifiable, but they were used for significant functionality such as role or access control in the application. And so we're able to do a privilege escalation in that case. Preventing issues in Cognito. So now that we've discussed some of the configurations, how to exploit them, overall what AWS Cognito is, these are some tips or some things to keep in mind as you're designing your application or assessing an application for vulnerabilities when using AWS Cognito. First things first, disable self-registration. If your user pool or if your application does not need to have a functionality to sign up new users, make sure you explicitly disable that functionality. If there are custom attributes that you've assigned to users in the user pool, make sure you make those immutable or don't let users modify the attributes. There might be unintended consequences. Of course, depending on the application, that might not necessarily be um, maybe the best way to make sure that the attributes are a certain way or not. But again, something to keep in mind. Disabling guest access. Um, context matters for all of these, so I'll just say that right now. Um, if it's not needed, definitely try to disable it to avoid scenarios where you might have um, maybe mistakenly assigned or associated a privileged role to the unauthenticated user in AWS Cognito. Defining least privilege IAM policies everywhere. Yes, even outside of AWS Cognito, you should define least privilege IAM policies. There's a lot of tools out there. There's a lot of great literature. So I won't go into that, but it's really worth it, especially if you're maybe far along in your um, security maturity model and you want to protect yourself from some assumed breaches scenarios or just generally speaking, some secure um, engineering practices, try to define least privilege policies. And then limit exposure of configuration IDs. So these are for user pools and identity pools. Again, these are kind of like reaches. I don't think they're nearly as critical as the other ones. But if it's so up in my face and I'm assessing an app or helping someone assess an app, these are things that I'm thinking about. Where are they? How do I get to them quickly so that I can start pivoting into the instance? All right. Additional resources. So I did not create, this knowledge or invent it. This is very much a collection of resources that things I stumbled upon, of things that I've stumbled upon as I've been learning myself about AWS Cognito and trying to figure out ways that I can exploit it. And so here are some links that have helped me. Um, Yeah, definitely take a look at them. As always, take a look at the security docs for AWS, the developer docs as well. A great source to understand what is going on. There's a lot of ways of configuring this, so please reference that. Yeah. Okay. Great. Thank you. That's all for today. Uh, Again, my name is David, and I think I added my LinkedIn profile. I don't have a fancy website, but you can find me on LinkedIn. And yeah, not really on too much social media either. But thank you so much for tuning in. I really appreciate everyone's time. And yeah, hopefully this will help you, help guide you in doing assessments or building out secure solutions when you're building with AWS Cognito.